Hello everyone, today we are going to talk about fractals. But first,
let me take a selfie.
Let me ask you something. What is the perimeter of France? Please go ahead, close your eyes, imagine the longest road you've ever taken. How many kilometers was it? 100 kilometers? 500? 1,000 kilometers? Well, now think about a road that is so long that it can envelope all the country. What would you say? You can write your guess in the comment section below. What does Google say? 2,913 kilometers. Well, let's verify this. Here we are on Google Earth. There is a tool that allows us to measure distances or even perimeter and areas of roads we select. If we go around and take the largest perimeter possible, we find something around 2,000 kilometers. Okay, now if we take the smallest path, we find also something around 3,000 kilometers. Of course, it is smaller than the first one. But what is exactly the perimeter of France? Google didn't say around 3,000. It says 2,913 kilometers. How can we find exactly this? Well, you may say, be more precise. So I decided to be more precise. Now we find 4,402 kilometers. What? What happened? Well, if we look closer, borders are not straight lines. And the fact is that a straight line is the smallest path between 2 points. On this map of Bretagne, we see clearly that we skip a lot of things. First of all, these lines are a good approximation of Bretagne, but if you zoom in, you can see that we could be more precise. We should definitely add a third point between these 2 points to fit the curves. But even at this scale, there are imperfections, and the curve is a lot more complex if we consider every rock, every grain of sand. And the more we add points before these 2 points, and that are not on the straight line, lengthen the perimeter. In fact, the perimeter of any country tends to infinity. What the fuck? This is a real paradox. How come a finite area can have an infinite perimeter? Here come mathematicians and their weird objects. Look at these segments. Cut it in 3 equal parts. Remove the central part, double it, and place these in a shape of a triangle. Repeat for every new segment. Repeat infinitely. And you get a Cauchy curve. This shape is called a fractal. Because we multiply by 4/3 at every step and we have infinite steps, the perimeter is infinite. The more we zoom in, the more details we can see. And the fact is that the shape repeats. This is one definition of fractal. Mathematicians studied these mysterious kind of shapes for years. It resulted that fractals are really common in nature. Cabbage, lungs, trees, all of these are in fact fractals. Lungs and trees maximize their area of contact with air to be more efficient in their functions. We see fractals everywhere at any time. For example, a wood table looks like a plane. look closer, touch the wood. You can see and feel some grains. If you look in the microscope, you can see that it is really not a plane. Well, everything is a fractal. Mathematicians also found that the Koch snowflakes are not really one-dimension shape and not really a two-dimension shape. The dimension of this snowflake is 1.26186, etc. In the case of our shape, the perimeter of France, we saw that the smaller the scale is, the longest is the perimeter. It can be resumed at this graph. The coefficient of this straight line is the dimension of the shape. The dimension of a shape is no longer a whole number. It has been generalized as real numbers. For a better understanding of real numbers as dimension, look at this one-dimension shape. This is called a segment. When you multiply it by 3, it is 3 times longer. A two-dimension shape, tripled, has 9 times the area of the first one, which means 3 squared. But as the Koch fractal isn't a 1 or a 2-dimension shape, when you triple it, you can count 4 shapes, like the first one. The dimension of the shape is 1.2686, which means that it is measured in meter at the power 1.2686. And we find that 3 at the power 1.2686 is equal to 4. Let's take some examples. The Sierpinski carpet has a dimension equals to 1.8927, etc. This figure is formed with a square. This square is divided in 9 equal parts, 3 columns, 3 lines of smaller squares. Then remove the central part. Now repeat these steps infinitely with the 8 other little squares. The Sierpinski triangle has a dimension equal to 1.585. The triangle is basically the same. Draw a triangle, cut it in 4 parts and remove the central parts. Now that you have the 3/4, repeat the same thing infinitely. These types of shapes are called orthosimilar shapes. Another orthosimilar shape, but in more than 2 dimensions, is the Menger's sponge. The dimension of the Menger's sponge is 2.726. It is an extension in 3 dimensions of the carpet. Last but not least, the Mandelbrot set. This shape has been discovered by Benoit Mandelbrot in the 80s. It is entirely described by this equation. Z is a complex number. The representation here is in a plane called the complex plane. Let me explain the formula. Z starts at 0. Pick a complex number, let's say I. This will be our constant C. Now square Z and add C. Repeat that to the infinity. If Z is stable, which means that it doesn't tend to infinity at the end, then it is in the Mandelbrot set. If it's unstable, then it's not. But sometimes it is way more unstable than other, which means that it tends to infinity really fast. So, mathematicians and computer scientists use a color gradient to indicate that. It is mind-blowing that all these complex shapes are only a small function that only square and add numbers. Let's zoom a little in the Mandelbrot set. You can see that it is also an autosimilar shape. So, let's resume the information we have for our first question. What is the perimeter of France? France has a finite area but an infinite perimeter due to the shape of borders. This shape is a fractal and has a real number as dimension. Thereby, the border of France should be in meter at the power 1.333. So, how does Google answer this question with a number or meter? Well, convention. Geographs measure the perimeter of every country at the same scale, which is 1 kilometer. Thanks to that convention, we can measure and compare countries with the length of coast or border between two countries. Although, did you know that the longest border of France with another country is shared with Brazil? Yeah, because this border is infinite. I didn't talk about the fractal behavior of stock market. For those who know the math, the curves of stock market is continuous but not derivable. If we zoom in the curve, we can see that the fluctuations are infinitely small because stock market is in a constant change and never reach a potential equilibrium. We can see the same behaviors in the shapes of sound. Voice, instruments, even no sound at all is a fractal because of noise. Fractals are also found in the theory of chaos, theory of animal populations, and way more applications. I suggest you to go watch this video of Veritasium. You may never see math the same way. Okay, now, vocabulary. Fractals. If you didn't understand that one, please watch this video again. Scale. The scale in this context is the smallest unit we take to define the perimeter of France. A straight line. A straight line in a plane is the direction that links two points to the infinity. Finite, infinite. Here, that's the pronunciation that is important. Cabbage, limes. I presume that you know what tree is, but maybe when I gave examples you didn't know what cabbage is. The expression at the power 3 is an expression well known by math crazes. Carpet, the Sierpinski fractal, looks like my grandma's carpet. Sponge, well, SpongeBob SquarePants. Behavior, it is the same word for the behavior of someone and of the curve. Noise, in physics, it is what we see when it is dark and what we hear when there is no sound. The derivative, it's the leading coefficient of every point of a function. Stock market, the Wolf of Wall Street. Logarithm, it is a different way to count. To guess, not the brand.